Yeah, James M. Gear. Yes, sir.
You see this book? This is a very, very good book for song. Okay, if you want to study further, if you want concept, then this book is fantastic book. What is this book? Beer and Johnson. Okay, very good book it is. See, all the topics are there: columns, deflection of beams, and the if you see deflection of beams, explanation will be very good. Problems and everything are very good problems. And one more book was saying, what was that book actually? I had that book also, James Gear. That's also a good book. Anyways, so we'll start from where did we stopped in the last class. What were we discussing in the last class? Anyone? So we were seeing about the Taylor's tool life equation. Can anyone tell me what is Taylor's tool life equation? Taylor's tool life equation. It says that Vt to the power n equals to constant, where V is what, T is what, C is what, N is what? Can anyone tell me? V is the cutting velocity. Okay. And it is the cutting velocity. What is the unit? What is the unit of cutting velocity? Meters per minute. Okay. What is the unit of cutting time? A tool life. If for tool life, it is in minutes. What is the C? What is C? Taylor's constant. And what is this N? Taylor's exponent. Okay. Very good. So we will try to solve some simple problems based on this, so that generally questions are asked in the end exam from this. మీకు క్వశ్చన్స్ దేని నుంచి వస్తాయి ఎండ్ ఎగ్జామ్లో చెప్తాను. One question will be from merchant circuit. Okay. Another is from this tool life equation. Another one is from the velocity, Vs, Vc. Okay. Relation between Vs and Vc. And another one is from chip thickness ratio, that is phi equal to tan inverse r cos alpha naught by 1 minus r sin alpha naught. సో ఈ ఇంకా ఒకటి లాస్ట్ ఏంటంటే పవర్. పవర్ మీద నేను మీకు ప్రాబ్లం చేయించలేదు, నేను చేయిస్తాను. చేయించకపోయినా మీకు నేను అసైన్మెంట్ ఇస్తాను, యూ కెన్ ఈజీలీ సాల్వ్ ఇట్ బికాస్ యూ ఆల్రెడీ నో వాట్ ఈస్ పవర్. వాట్ ఈస్ కటింగ్ పవర్? Cutting force multiplied by velocity. So if you do it, you will get the power directly in watts, and if you divide it by 1000, you will get it in kilowatts. Anyways, I'm writing one problem. You have to solve it. Everyone have to solve it in an orthogonal machining. Operation. The tool life obtained is 10 minutes at a cutting speed of 100 meters per minute. While 75 meters per minute cutting speed the tool life is 30 minutes. Find the value of index and Taylor's tool life. Solve it. Completed. By this time, it should have been completed. Are you trying or should I tell?
Sir, we're trying, sir. Please give us some more time.
Hmm. Others are also trying. Manikanta, Siddhartha, Sheikh. Asha, Kiran, Santoshi, Janvi, are you there in the class today? Today, very less students are present, 36. Maybe this is your time of sleeping. You won't get up by this time. Most of you are present. Okay. Santoshi, answer చెప్పు.
Sir, 2 minutes, sir.
2 minutes కావాలా నీకు? 2 minutes కష్టం
Yes,
ఇవ్వడం.
sir.
సరే నేను సాల్వ్ చేస్తున్నాను, మీరు సాల్వ్ చేయండి. సో what are the data given? First, this is that write the data in orthogonal machining operation. In orthogonal machining operation, tool life obtained was 10 minutes. So the first tool life was 10 minutes. Okay, cutting speed V1 equals to 100 meters per minute. Now what is T2 and what is V2? 30 minutes and 75 meters per minute. Okay. This is the given data. So we have the equation Vt to the power n equals to constant. So can I write it like V1 T1 to the power n equal to V2 T to the power n, since it is constant? Can I do it like this? Now what is the value of V1? 100. What is the value of T1? 10 to the power of n equal to V2 is 75 multiplied by 30 to the power of n. Okay. Now what I will do is 100 upon 75 equals to 30 upon 10 power n. Now if I want the value of n, what should I do? I should take log on both sides. So log 100 upon 75 equals to log 30 by 10 n. So what is log m raised to n? I will get log 100 by 75 equals to n log 30 by 10. So n equals to log 100 by 75 divided by log 30 by 10. How much you are getting? Tell me how much you are getting. 0.261. Why did it took this much of time for you to solve this? ఇప్పుడు అందరూ చెప్తారు. So easy question. So easy. Okay, let us solve one. Typing in calculator. Only this value you require, na? Hemant will calculate. Other value you don't require. Okay, one more question. Try to solve it quickly. In a machining operation, doubling the cutting speed reduces tool life to 1 by 8 of the original value. The exponent n of the Taylor's tool life equation is, solve this. Hmm. 0.33 is the right answer. Right, Janvi, correct answer. 1 by 3 or 0.33333333. Right. Okay. Okay, let us solve it quickly. For those who didn't solve, almost all of you have solved it. So we have an equation v1 t1 to the power n equal to v2 t to the power of n. So it is saying that v1 t1 to the power of n, if the cutting speed is doubling the cutting speed, means 2 times of v1, and the tool life becomes 1 by 8 of the original value, which means that t1 by 8 to the power of n. Okay. So this v1 and this v1 will get cancelled. I will get t1 to the power of n equal to t1 to the power of into 2. Okay. Now just a minute. v1 t1 to the power of n equals to 2 times of v1 t1 to the power of 8 all to the power of n. Now I will rearrange the terms. I will take this v1 upon 2 v1 equals to t1 upon t1 into 8. Okay. v1 will get cancelled, t1 will get cancelled. 1 by 2 equal to 1 by 8 to the power of n. Now taking log 1 by 2 equals to n log 1 by 8. So n equals to log 1 by 2 divided by log 1 by 8. So this you will be getting as 1 by 3, n equals to 0.3. Okay. One more question. This is a good question. And all these questions are previous year good questions. Okay. In a single point cutting operation of steel with a cemented carbide tool, Taylor's tool life exponent is 0.25. If the cutting speed is halved, if the cutting speed is halved, the tool life will increase by how much? This is also a gate question. All these questions are gate questions. Solve it and tell me the answer. Okay, done. Have you given the answers? No? Let us solve this. So what has been said in the question? Single point cutting tool with a operation of steel with the cemented carbide tool. What is this cemented carbide? I will tell you. Okay. This is a tool material actually. When we will discuss about tool materials in Monday's class, I will tell you what is cemented carbide in detail. Taylor's tool life exponent is 0.25. So N is equals to 0.25. Okay. The cutting speed is halved, and what will be the increase in tool life? So V1 T1 to the power of n equal to V2 T2 to the power of n. V1 T1 to the power of n, if the cutting speed is half, he is asking that by what amount the tool life will increase. Okay. So V1 2V1 upon V1 equal to how much it will be? T2 by T1 whole to the power of n. So this 2 and this 2 will get cancelled. Here you will have 2 T2 by T1. This is 0.25 T2 by T1. 0.25 is nothing but 1 by 4. So this 4 will go there. It will become power 4 T2 by T1. So T2 equal to 2 to the power 4 is how much? 16 times of T1. So the tool life will increase by 16 times. Tool life increases by 16 times. No one solved this question. Why? No one solved this question. Why? Any reasons?
Sir,
Did you?
we texted,
We
sir.
solved it, sir.
Uh-huh. What did you say?
We all
We did,
solved
sir.
it, sir. It's in
You
the
gave the
chat.
answers? You didn't
Yes,
solve the
sir.
answer? Just a minute. Okay. Okay. Now the last topic for today's class is mechanism of tool wear. See, all of us know that there are two type of wears. The wear which is happening on the rake face, which we call as crater wear, and the rake which is happening on the flank, which is we calling as flank wear. So can you tell me what is the reason for these two wears to happening? What is the reason due to which this wear is happening? Anyone? Quickly tell me. What might be the reason? You don't tell me like temperature increase. Why temperature is increasing? Why there is an increase in temperature? Continuous shearing. So what is happening due to continuous shearing? On the rake face, no shearing is taking place. On the rake face, no shearing is taking place. Even though on the rake face, wear is happening, which we are calling as what wear? This is crater wear. It is happening on the rake face. So here no shearing is taking place, even though wear is taking place here. Why? So basically there are some mechanisms of wear due to which the wear will be taking place. Okay. So that mechanisms is different from the type of wear. Okay. So in the exam, if they ask you that write about the mechanism of tool wear, then you have to write these mechanisms. If they ask you that what are the types of tool wear, then you have to write about the flank wear and crater wear. Okay, you better be careful with this because most of the time students get confused. When they ask about the mechanism of tool wear, they write about the crater wear and flank wear. You should not write this when it is asked mechanism of tool wear. Mechanism of tool wear is the reasons due to which this wear is happening. The first reason is adhesion. Okay, just check the spellings. If there is some mistake in the spelling, just let me know. The second is diffusion. Okay. Third is abrasion. The fourth is oxide formation. Now, what is this adhesion? Adhesion means when you are doing the machining operation, so you might have observed in this diagram I will show you. So the chips will flow over the rake face, something like this. Okay. So you can say that there is a lot of high temperature which is generated on this face. Lot of high temperature due to the continuous flow of chips. So what happens is, due to this very, very high temperature, what happens is at the chip tool interface, the chip material and the tool material will start to weld with one another. Small, small spot welds take place on the chip tool interface. Maybe here one spot weld will take place. Here one to spot weld, here one spot weld, here one spot weld, here one spot weld, here, here, here. Small, small spot welds will be taking place due to very, very high temperature at the chip tool interface. But since the chip is flowing at very high velocity, what happens that these spot weldments are broken. So when these weldments are broken, what happens is that some material of the tool is also there in the weldment. So that material also gets broken and it is taken away with the chip. So you get some defects on the rake face or on the flank face as well, because on the flank face you don't have chip flow. So that's why this adhesion is more on the rake face. That is one of the mechanism. Understood now what is adhesion? Now another one is diffusion. Diffusion happens at high temperatures. That at a very, very high temperature, atomic transfer takes place. Means atoms from the tool might transfer to the workpiece, and atoms from the workpiece might transfer to the tool. At very, very high temperature, such diffusion of atoms will take place. And this diffusion of atoms is accelerated when the tool material is having a great affinity towards the work material. I will give you one example. We never machine steel workpieces with diamond tool. Okay, స్టెయిన్లెస్ స్టీల్ కానీ మైల్డ్ స్టీల్ కానీ మనం ఎప్పుడు కూడా డైమండ్ కటింగ్ టూల్ నుంచి మషినింగ్ చేయండి. వై? బికాస్ దిస్ డైమండ్ హ్యావ్ కార్బన్ ఇన్ ఇట్. సో దిస్ కార్బన్ హ్యావ్ గ్రేట్ ఎఫినిటీ ఫర్ దిస్ steel material. So when you machine with diamond, what happens that this carbon atoms will diffuse and they will go into the workpiece. So from the tool, these carbon atoms are diffusing, they are migrating, due to which the tool will fail over a period of time. So if you machine copper or any other non-ferrous workpieces with diamond tool, you will get a tool life of 100 minutes. Okay, let us say. But if you are working it with steel, you will get a tool life of 20 minutes, which means that there is a premature failure of the tool. That is the diffusion. Okay, clear up to here? Clear up to here or not? అర్థం అవుతుందా మీకు? Say yes or no? Yes. Okay. Now the next one is abrasion. What is the meaning of this abrasion? See, the chips are never smooth. The cutting chips are always, they are like this. So if you see the underside of the chip, it is more or less like a saw. So when these chips flow over the rake face, these protrusions will have an abrasive action on the rake face. Okay, they will have an abrasive action on the rake face, and due to this abrasive action, the tool might get damaged. The next is the oxide formation. So when the temperature of the tool is increased to a great extent due to the continuous machining, on the surface of the tool, oxide formation will take place. Oxide formation, you know what is oxide, right? So oxidation will take place at such a high temperature, and oxide layer is formed. Oxide layer of that particular tool material is formed on the tool rack face or on the flank also. So this oxide is relatively less harder, or it is of the inferior grade when compared to the tool. So what happens is, over a period of time, when the chips are flowing over this oxide gets washed away. This oxide gets washed away, and with this oxide, some useful material also gets washed away of the tool, right? Is it okay? Fine. Did you got it? So these are all the mechanisms of tool wear. And if I want to show you the same mechanisms in your notes, it is explained in a beautiful way. Most of you are saying you want handwritten notes. These are handwritten notes only, no? See here. See here, diffusion, oxidation, abrasion, agitation. Okay, all these four mechanisms were explained in full detail. So you can go through it. Fine. At the start of the class, while I was solving problems, only 20 students were present. Now I am taking attendance. There are all 54 students are present. If you just want attendance, you just message me in the WhatsApp. Okay, sir, we want attendance. That's it. I will give you. Don't worry. You don't have to come to class just for the attendance. Students. Okay, thank you very much. You can leave.